Okay, the subject is software architecture for autonomous systems. So for today, we'll take just introduction. We will just maybe know what's the autonomous system, what the autonomous system is, and its properties, and some example of this autonomous system. So here is about me. I'm your lectures in this subject. I'm the coordinator also. So maybe you will find about me in the website, UMB website. So here the assessment. Okay, guys, as you know, this subject is project based. Project based. So there is no final exam. You have what we can say it's to submit three project or three parts of your project. So this is the project. This is the project which is take 90%. 90% of this assessment goes to the project. So I divide it into three submission. First submission 1, submission 2, submission 3. So this will be group and individual in the same time. Group project and individual. What I mean by group and individual, you will work together because this subject also there is assessment for group, what we can say is team work. Okay, so we have some in this part we have individual and group. So in the same times you work together, and also some parts it will be individual. Okay, in your project for each submission there is some part for individual and some part for group. So later I will show you when we start discussion about the project. I think by next week you will see what's mean by project, I mean individual and group. Here we have some labs. Just apply what we learn. Okay, just apply what we learn. We have some example. For example, I will teach you something like what we can say is okay architecture for some in one example, and then I will give you another example. You will just apply what you learn in the lab. Okay, we have two quizzes. So in total we have two quizzes and labs, 8 labs. Not exactly 8, we will see 8, 5. Okay, and then the total is 100. So do you have any question regarding the assessment, guys? So if not, we go to the next.
No, sir.
Okay. So today class actually, as we say, we just start with motivation. Why autonomous system, and then the types of, in general, we can see the devices, the available devices, the type of available devices, the definition of autonomous system, the properties, its importance. Why it's important? Because you will select your project based on these properties. Okay, so later don't select normal project or normal system and then you say this is autonomous system. Okay, so you have to learn what's the autonomous system is, and then the components of the autonomous system, and then how the control, we can say, the in device in general. Actually, I do want to talk about the robot. The robot is kind of autonomous, but when we talk about autonomous system, actually it's come to our mind is the robot. Okay, because we can see the obvious example of autonomous system is the robot. And then we end with two examples of autonomous systems. So guys, why we study this subject? Actually, okay, now you learn maybe during your study how to analyze and how to design the, we can say, the information systems, the other systems. Okay, that one is just required just input data and output the data. That's all. This is what we can call it's the normal one, or what? This is the information systems. So, but as you see now, many systems now it's become uncertain information. I mean, it's working on information, and this information it's uncertain. So it's not just input and output, and these systems also interact with these environments. Okay, so this kind of system actually it's need another architectures, need another design. So here we come with these designs with this subject to learn how we design such such system. So here the idea, there is not all the system is just input and output. Not all the system is just key in the data and show the report. There is some environment, or we can say some systems react based on the current, what we can say, input or current times. So also, so the failure is not only based on the input, but also based on the input of the, or we can say, is the current status of the environment. Also, it's some of them is based on the current times. Maybe if the same input it's come now, maybe after 1 hour, the same input, but will be different output, because now they are in the different state. That's why we need another, we can say, another concept, another study for this kind of systems. So what we need, this is actually about the first point. The systems now is become different, and most of the systems become not automatically. So that's mean we have a sensors, we have not only the keyboard, the input, not only keyboard. The input become now different input or different type of devices. What I mean by devices, that's mean maybe there is a sensors, maybe there is a, okay, maybe in general we can say sensors or camera, or this is all kind of inputs. Not only same before, okay, input from the keyboard. So this is the first one, because we have different systems now. If you see around you, you see everything now in your mobile. Not just, okay, if you want to open the mobile, you have to key in your PIN number. No, you can use your fingerprint. This is also one kind of input. So what we need in the second point, what we need system that automatically adopt itself, automatically react based on this input. Okay, and this is actually, it was dream to do it, but now because the technologies, it's become real. So now we have different kind of systems that's it's situated in the environments, and so we need also different kind of architecture of design for these such systems. So this is why we need to study this kind of systems. So guys, let me see, is maybe somebody want to join? No one. So maybe it's come from WhatsApp. Okay. So back to our slides. So okay guys, this is why we go for autonomous system. So here also is a motivation. Why? Because now in our environment or in our life, now we use this kind of systems, this kind of we can say it's devices. So here, if for the some example, this is just example, just in, for example, if the personal service. So here now maybe you find house cleaning. Many devices just use some kind of machine that it's work autonomously, work by itself without any control by the user or by the humans. Also the office assistance to the elder people, also in the security. So all these kind of devices can be considered as autonomous, or at least is semi-autonomous. Okay, so this is These devices, it's now, if you go now for any places and you want to, okay, go to the security, maybe you don't have to tell them or to write your name and my name. Okay, just maybe use your card or use your fingerprint to access to this place. So here's some example of this type of the personnel. Also here another also example, which is like the, as I mentioned, is the automatic door, automatic or automated planes, also the room partitions. So many kind of example nowadays. It's autonomous, considered as autonomous system, and we need to know how we analyze and how we design such systems. So here we can see now we go to the another topic, which is the classification of devices based on or the system based on the operations. Here what I when I ask you the first things is about, can you give me an example of autonomous system? So some of you they give the drone. So if I talk about that, we say drone, is it autonomous or not autonomous? So this is here we have some properties or not properties here, maybe say some description for these devices. So based on the operation. So based on the operation, we can consider this is it's autonomous or it's we can see semi-autonomous or it's manually. Okay. So what we how we can say this is it's autonomous or not? So based on the operation, based on its operation. Okay, some I remember last semester that some student they come to me and ask, we want to take this project, this topic as a project. So they ask, is it autonomous or no? You know, sometimes I tell them it's autonomous, but when they analyze it, and they start study this based on their data, I can say, oh, this is the one you study is not the autonomous one. Okay, the one you study is not the autonomous one. What I mean by that, that's mean the operation in this system can be autonomous and cannot be. Okay, but if you want it autonomous, maybe you just have some input, insert an input. This one we can say this is autonomous. We have, for example, also the interact of this system. If the system interacts, it's automatically, so we can say also this is it's autonomous. But if you say, okay, I remember exactly, okay, one is the smart house. They say this is example of autonomous. Yes, 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 this is example of autonomous system. But in the end, when they study this system, they just put some, because we have, okay, in the beginning of our project, I ask them to list the requirements. You know what's mean the requirements in software engineering. I ask them to list the requirements. So they list the requirement and I read the requirement. It's just, this is normal system. Normal system. There is no, anything is related to the autonomous. It's not autonomy anymore. So based on in your description, based on your also operation of the system. So here we can say there is the description of the available systems based on the operation. So we can see the first one is the autonomous. So the autonomous mean have the freedom to act independently. Okay, therefore the machine are completely self-configuration and supporting. So here, if the system or the machine it's work by itself without controlling by another devices, I mean can control itself, also can configure itself, so this one we can say it's autonomous. Okay, this is first. Second, also we can say is standalone system. Standalone system is the same thing what we say, not controlling by another device. Okay, so now if we come to the Ahmad example, what he says, see the drone. Okay, the drone. Okay, we have, this is the drone. Okay, for example, and we have another, it's the remote to control it. So this is not autonomous. Okay, but if If, for example, we have another version of this drone, okay, there is no remote, and this one it can just maybe we start it and it's okay based on the environments or based on its goal, it can do its goal. So this is we can say is autonomous. Okay, so based on the system or based on the function of this device. So here also the second thing, this is what we say. Okay, later maybe there is another thing what we can see is it can understand the environments. That means can receive the information from the environments and then analyze these environments. Okay, so this is also we can say this is autonomous. The example, okay, as you say, as your friend say, whose name because okay, one of you he say is the Romba. Yes, Romba is an example. Also in the same things, if Romba not it's Romba it's an example of the autonomous system. But sometimes if you describe, okay, it's just maybe you know sometimes if you just start and close it, this is also we can say this is not autonomous. So what we can find here, most of the system here, it's now semi-autonomous. Semi-autonomous, not fully autonomous. So this is an example of autonomous system or this kind of systems. Manual system, okay, maybe you know manual system. Manual system that means everything is okay or do the task not independently. Everything's based on another maybe another instruction from maybe from the human or from the another devices. So this is manual. So we have the another one, or which is the most common one, which is semi-autonomous. So this kind of machine, it's not manually and not autonomous. Okay, as I told you, this is the example of the drone. Many example actually, many example. It's we can say it's semi-autonomous. Like okay, the vacuum cleaner, this one because some of them okay we can say it's fully autonomous, but some okay for example maybe later I ask you, I give you an example and you tell me why. Okay, this kind of systems have degree of autonomous. That's why we cannot say it's fully or we cannot say manual. Okay, they take data using the sensors integrated on and get information from the human control. So this one, what I say is controlled by another device or maybe human itself. So here some examples here of this, as we say, the vacuums. Okay, why we say is the if you see the description here, I give an example of semi-autonomous machine or anything you can say is machine. Okay, is the vacuum that can clean the room by dynamically navigates around the people, cat, and furniture, and it stops after finishing the cleaning. Here we can say not fully autonomous. Not fully autonomous. Why? Okay. Some of these vacuums you started, okay, and then it's work by itself. Okay, we have this room for example, and then it's work by itself. It's work by itself. So find if there is any obstacle, they will try to avoid it. If there is something, they will clean it and finish cleaning. Okay, you come and stop it. You stop it. So this one actually we can say, oh, this is still not exactly or not fully autonomous. Some other devices you will find here in the market now. Some is the same vacuum. Sorry guys, I'm writing in the screen, so it's not really tidy, but it's okay. The vacuum, maybe you start it, okay, and then it will clean the room autonomously. That's mean if there is that's here, it will take it. If there is here, it will take it. And the second thing, if there is any obstacle, they will try to avoid it. Okay, finish its job, it will stop by itself. You see, this is also, that's why he say we see there is a degree of. So this is, it's, we can say if we give this one, we give them, okay, 8 from 10. Okay, and this one is maybe better, we give him 9 from 10. So there is degree, because here why it's stopped by itself. What, once it's finished its job, that's mean all the room it's clean, there is no dots, there is no there is nothing need to be clean, so it stopped by itself. Why? Because maybe when it's moved, they have a sensor to find if any dots there is any, so there is no more, so it stopped by itself. But here maybe it will continue working until the user come and stop it. So based on, okay, based on. So maybe we have another system. Maybe it's not even you not start it, you not stop it. Okay, maybe they have is already configured by itself, or okay, we have time to start, or maybe we have a camera to find. Okay, if there is any deaths, it will work by itself and then stop by itself. So maybe we have another degree of also. Maybe you can say higher than second one. Okay, so we cannot exactly say this is autonomous or not autonomous based on the operation, based on its operation. That's why we classify this into three kind of systems: the autonomous one, manual one, which is the opposite of the autonomous, and between them it's semi-autonomous. Okay, maybe this is the answer why we say here, because such machine accept the command from the user, such go and stop. Okay, okay. So there is the decision actually also it's still based on the human user, based on the user. So that's why we say this is not fully autonomous. There is some decision still based on the user. So guys, now we come to our definitions. The definitions here start just as we say. Okay, we start with some example of autonomous systems, or that exactly not exactly the autonomous system, but we say the definition or the classification of the systems, the available systems or available device or systems. So we mention the type of devices based on the operation, and then here we can say, okay, now these devices, we can say if we want to say this is autonomous, it's if it's perform the behavior or the task with high degree of the autonomy without external influence, without external influence. So this one we can say this is autonomous device, and then need autonomous system. Okay, this is if we talk about this autonomous system. Here actually you can find some links. Okay, you can click and then read about this topic. Okay, so because autonomous is related to this topic, so just for more information just click and read. So here we have the autonomous robots, or the autonomous machine is usually considered to be subfield of artificial intelligence, robotics, and information engineering. So we say, what's the autonomous system now? I say here is a computer system. It's, yes, is a computer system. Is a computer system. It's not computer system, doesn't mean it's in the computer. No, it's a system. It is a system. Even it's in the computer or in there, but you know, anything it's a computer is not just the computer that you learn or that you know. The computer is, that's why they put it, this is a copy from the one book, and then I share 3 reference there in Kalam. So is a computer system, we can see is a system that situated in some environments and able to react autonomously in these environments in order to meet its design objective. So this is the formal definition of autonomous system. That's why here before I just define, or what we can say is define the autonomous machine, but the system itself, it is a system. So the one it's work in this kind of machine should be autonomous system, and this autonomous system is, as we see, is situated in some environments. So if just one system it's in your laptop, so this is not autonomous system. When you have a robot in the factory, so it's not autonomous. If you have a robot to in, for example, even okay, the door lock open and close, and this is also we can say is autonomous. Even it's semi-autonomous or have some degree of autonomous, but it's autonomous. Okay, but if something like okay, receive information and then output the information, this is not autonomous. Okay, one thing, guys, maybe we don't we talk a lot about the robot. I mean, don't think that's the autonomous is the robot. No, we have another kind of systems. Even in your in your laptop, also there is it's work autonomously. Okay, you know, guys, Siri. You know, Siri. This is we can say it's just it's a software. It's a software. But this one actually it's based on artificial intelligence, and this one also kind of autonomous system. So not just a robot, autonomous, not just a robot. Okay. So here, why Siri? We can consider Siri as, you know, guys. Siri, what is it?
Yes.
Yes, Alhamdulillah, you know it. Okay. So this guy, this thing is we can consider it as type of autonomous. Okay, that's why, because it's receive some information and then sorry process this information and they react based on this information, and also they have uh, objective, or it's have a goal, so need to achieve that goal. So this all is the properties of autonomous system. Later I have list of properties. So once you say, oh, this is okay, this is we can consider. So it's not only robot, it's not only drone, it's not only the vehicles. Okay, other kind of system, even it's only in your laptop, also can be as a system, as autonomous. So the second point actually also it's for the basis of more advanced algorithm, which is empower the mobile robots to explore unknown environment autonomously. Okay, okay. It's same guys. Explore the environments. So here guys, advantage of this kind of system. Okay, great flexibility and programmability. So more flexible. Also, it's response on time. Of course, response on time. Okay, improve the product quality. Guys, actually, it's clear now, guys. Clear, right? Clear everything. No need to explain what. When we say it's improve the quality, okay, this one maybe we say how is improve the quality. As you know, guys, uh, they work using sensors. Also using some artificial intelligence algorithms. So the measurement it will be a very accurate. So maximize the capital intensive equipment in multi-work shift. Okay, this one also maybe the human he will work one shift, but there he will not, maybe it will work the whole day. Accident reduction, of course, the accident reduction, especially if we use for some kind, it can be used in military. So there is the high risk there. So you can use some autonomous robot. It can do the job. Okay, automation is less susceptible to work and stupid. So guys, this is just some kind of advantage. So here the disadvantage, maybe we have another's, but just it's the uh, maybe there is two which is, guys, it's replace the human. This is the more important ones. Once we work in the autonomous devices, so we replace the human, maybe in the factories, in the security. No need now for security to stand in front of the building. There is only one device can record the information, also alarm if there is anything is unusual. So many the main problem is reduce or replace the human. Also, the second thing is actually maybe, as we say, there is some, they call it here hiding cost. Maybe you say, okay, maybe it's better to use the autonomous devices, but in the end, it's also its cost is not like human, but I mean there is some hiding cost. Okay, as because you are using the technology as not one the technology not free, so you have to pay a lot. I mean for that one also for maintenance for many things. Just not okay. You will buy the system and then done. But okay, there is another hiding cost you have to pay. So here, guys, this is actually I want to delete these three slides, the coming slides. But okay, in the end, I say okay because I don't want you to just say okay. We are talking or we are study or our subject is robot. No, our subject not robot. It's kind of autonomous. But as I told you before, once we take autonomous devices, so it's come to our mind is the robot. Yes, is the main, or we can say the obvious example of autonomous system is robot. So here we have different type of robots. We have the mobile robots. I just goes faster because as I say, it's just examples. The later we have another example, which is more details. This one just what we mean by the mobile robots, what we mean by the stationary robots and autonomous robots and remote control robots. So mobile is actually the one it's can walk around the area, and we have here many kind of robots, and most of them should have wheel or should have legs. So this is just example of the first one. The second one is walking because also the same one now on under the mobile robot. Later when you select your project, you can select one of them and then also back to these slides. Stationary robots. Actually, this is just the one you find it in the factory, and this is actually it's do the same job frequently. The same job they do it. So for example, cutting the products. Okay, you have the product and you need to cut this product. So just cutting, and this is actually we can say it's kind of autonomous. Even we can say is because they do it autonomously, but it's only one job. Okay. So here the autonomous, as we say, it's mostly something is self-supporting, also self-configuration. What's mean by self-configuration? Self-configuration because it's situated in environments. So based on this environment, they can adopt themselves. They can change the configuration and react based on these environments. So the autonomous robot run a program that gives them opportunity to decide on the action to the programming depends on their surrounding. So in the end also they have aim, they have something or they have the object and they want to objective and they want to achieve that objective. Also autonomous is robots can learn. This is guys when you select your project also you have back to this description. Autonomous robots can learn to work or avoid the obstacle. Okay, similar to the vacuum. So avoid the obstacle. Okay, maybe not only vacuum, but other kind of robots. So can walk also avoid the obstacle. For example, is six legs robot. We have I think in the next slides. No. So here, I mean, this is okay. For the next, we have one example for the six legs robot. This one actually because why six? Because is it? Yes. Sometimes it's to make the movement is flexible. So we have many wheels, many, and that's why we have some robots like a circle. It's just okay for flexible movement because this one actually maybe can move forward and backward, right? And but maybe in the same place you can turn right and turn left is difficult. So they make it like this, and some of them they just have one wheel here. Okay. Okay, guys, this is if we talk about the properties. We say we have now two two main properties. Two main properties. Okay, we have another here, a list. This is all the list. Okay, all the properties. But there is two main properties. The first one actually is, we can say, is independent. Independence. So here the system, or yes, the system is work independently and work based on the own decision. Okay, so this is the first properties, and I think we explain what's mean independent. That's mean don't need any instruction from the human and can make the decision based on the by itself, because the second one is the situated. So the system should be situated. That means it's in the environments and we can say can work and adopt itself based on these environments. Okay, so the first one is independence and the second property is situation. We have many, but this is maybe the main two properties. The system is independence and situated. Okay, we have another two properties which is reactive and proactive. Okay, reactive, that means if there is any action, it will act for this based on this act. No, if there is any situation, it will act based on this situation. And then proactive, it has a goal and then need to achieve that goal. So for example, okay, in the vacuums, okay, I mean, if we say what's the active and the proactive, reactive and proactive, okay, here we have the obstacle. So once the vacuum is face this obstacle, we just move. So here, based on this problem, so it's response based on this problem. But in the end, do not stop here. They should continue until reach the goal. Okay, reach the goal, which is, for example, cleaning the room. So proactive here, we have to reach the goal. So this is the second properties, but here I just explained two. So reactive, response on the time, response on the time. So just maybe you have the problem, just see what the problem is based on the sensors, based on the camera, based on anything. Just receive what the information, I mean this information, and then react based on this information. And in the end, don't stop here. So you should do proactive. That means continue works until you achieve the goal. This is active, or we can say it's okay. Flexibles and social properties. Flexibles, is it this one? Okay. Flexibles, actually, okay, we say we have a goal, so we have to find solution if we got any problem. So we have many ways to achieve our goal. We have to find, I mean, this is the one properties of the autonomous. Okay, the vacuum is stuck in one place, so we should do not, okay, even now maybe stop cleaning, and now your job, okay, to skip this obstacle, to find way to move from this obstacle. So here we should have many way to achieve our goal. Also the social properties, actually, okay, as we say, it's can work with another things. In general, we can say another things, or another also type of another systems. Okay, social, that means can work with another system. So here maybe I listed here again. We see is situated. That means it's exists in some environments. Autonomous, also it's work without influence by the human. It's work independently without influence by any human, or any, not only human, any other devices or any other human. So reacts, that means response on the time. You have problem now, you fix it now. You response based, not just wait, maybe later we see our owner to what what we have to do. Proactive, okay, achieve the goal, Flexibility, as I mentioned, we have many, we should have many way to achieve that goal. Okay, robust, that mean, okay, in case there is some failure, you should recover. In case there is, this is maybe we don't mention it before, but okay, the robust does mean, okay, not okay, face problem and then stop. No, you have to find a way to, in case there is some failure. Social is interact with other agents. Agents actually, also we can, some books they, when they talk about the autonomous system, they say is agent. Okay, so the agent, especially in our Siri, this is, they call it is agent. So guys, this is the main properties of the autonomous system. This is the main properties of autonomous system. Okay, situated is the most important one. Is situated and autonomous. Situated, that means it's situated in some environments and then can react based on these environments. And autonomous, okay, without influence by another, by others, by other things, for example, devices or another or human. And then react, proact, flexible, robust, and social. So here the another things is not properties, but here how it's work. What here we call is the control loop. Control loop. These systems or these, yes, these systems, how it's work. How it's work. So guys, maybe I already explained during the talk. I say the system actually receive the information. After receiving the information, this is when I talk about, when I ask you where we use this artificial intelligence. So after that, after receiving the information by the sensors, here you see we talk about sensors. Even if there is keyword, this is, we can say is input. So here the input, our systems is different than the normal system, which the input only come from the keyboard. The input come only from the keyboard, but here the input come from many devices. So we have a sensors, we can say is a sensors in general. That's why later we will learn what kind of input do we have. We have user device, we have another devices such sensors, camera. Even the camera, guys, it's considered as a sensors. Because what's the sensor? Just, okay, device to receive the input, for example, receive the light, receive the, maybe the touch. So the same thing, the camera is receive the light. So we can consider sensor, a camera as a sensors. So we receive the information using these sensors. So the sense here, just to receive, the sense is just the action, the act of receiving the information using sensors. So if you see here a lot of things. After receive, now when we talk about the artificial intelligence, so this information now we sense, after that receive this information, now we have to plan. After processing this information, we have to plan what the next. So if, for example, you receive it from the camera, so you have to process this camera or this image. After that, you see what's the action that you have to do. Okay? And after planning, that's when we use some methods, some algorithm to plan or to make a decision. Then we come to acting. So based on this information and this plan, after that, after we should to act. And then back to the same loop. So this is the general, or we can say the control loop of the autonomous system. Since the system, we can see the environments, after that plan based on this information received by the environments, after that act based on this plan. Guys, is it okay until now? Just as we say,
Yes,
just
sir. Yes,
introduction
sir.
is nothing new, nothing new. Okay, next. Just, okay, because you know why I say next, it's maybe now we have only two example. only two examples just to, that's mean all our class may be already now done. Just we take the system, some the properties of the system, and then now the control loops of the system. Also the type of systems. So here the first example, which is the robot vacuums cleaner. So what we will learn here, just how we can say the architecture of this. Just a few things, not we will not go for details. Because guys, in our methods, in our subject, we will not go for hardware, just design, just the design. So even during the project, just maybe we design the internal, or we can say the software, not only, I mean, we just, but we should to learn, we should to learn the components and what devices in this, or what the parts of these devices, of this device. But in the end, we focus on the system, or the design of the system. So here just maybe just is the some information about this report. Say we have what sensor do we have here in the report? Okay, we have the dirt sensor, we have bomb sensor, we have the power sensor, we have the bag sensor. So this is just sensors I provide you here. I think is this is the type of, yes, this one I think. Okay, is it show the sensors? No, this is just to move. This is for movement, to control the movement here. There is no sensors. Actually, there is a sensors. Battery, contact points for the home base, wall. Okay, this is no details here. Sensors opening only. So guys, okay, this is an example of the vacuum of the robots. We can see this is semi or fully based on the design, based on the design. So here we have some sensors, and this sensors actually later when we study or when we analyze the design, this is, we can say, is input devices. Okay, input devices. So each input devices will be considered as one components. For example, we have the dirt sensors. So we have the bomb sensors. So each one is interact with the system. If you remember in use cases, right? So this is actually now when we will design, for example, the use case for this system, for example. So here you have to know, we should to find what the actors. So here actually it's the sensors, we can consider it as one actors. Sensors, because in this system we don't have, for example, user to key in the, or to give the instruction, or to give, so we have sensors. So the sensor is actors. So I mean, why we need to find this information about the system? Because this one what we focus about. When you study the system, we should to find what the components of this system or these devices. So here, this is maybe something, it's the motors, the wheels, and here based on your system, here we sometimes, as I talk about the wheels. Okay, for example, you talk about the movements. So how we can make the movement is flexible. So if you see here the design of this, most of them is actually is a circle. Why circle? Because to make the movement is more flexible, you can move for any place, you can get out from any place also. So the second thing is also the wheel. The wheel here, when they put small wheels and one wheels only here, so the also see here one wheels, it's not, this is, I don't think this is the wheel. So it can make the movement is more flexible. So in your place, you can even turn in same place. I mean, in the same place they can turn. But if it's, for example, is a square or rectangle, so it will be difficult. Also, if we have four wheels is the normal wheels that you know, it's be also the bit difficult. But they now they put not wheels exactly, but like ball, so it will be easier. Maybe we have only one ball, and we have one ball like this system. We have one ball, and the other is wheels. So guys, as we see here, here is the design, the internal design. We can say is the components of the system. Okay. This is also action and reaction. They say, okay, here, action and reaction. Actually, this is uh, based on the system. As we say, sometimes it's just the system or the machine is just cleaning, whatever. Okay, but some of them they sense is there dirts need to be clean or no. Okay, but some now this is the cheap one. Just you find the device and device just moving around the room, even there is dirt or there is no. So here, for example, if we talk about the anomalous, for example, just at least sense there is dirt or there is or just clean. If clean, maybe you stop. Action, actually, it's go forward or backward based on the this dirt. Here, maybe this is the available model or available products. This is continue the previous slide. Just guys, some like this. Okay, I mean this is as we say is just case study. I mean later you maybe if you want to learn more you can read about it. Okay, so guys here this is the design of, for example, when we come to analyze the system, actually we should come with some time in the end to verify also the system, to verify those. This is what we have to do is to create a model. So this is also we can say is the model of these vacuums, model of these vacuums. So we see here we represent the system, the same system, but using state machine. State machine actually it's represent the system as a state. So for example here in this node, starting node, because it's double, so we are maybe if you come from formal method you will know what this is a model. Now just in the beginning just wandering, so finding if there is any or moving around, moving. So if they find obstacle they try to turn, and then after turning just back to clean. And the same thing here, if is there's dirt, so take this dirt, it's fine. If there is any dirt, take it and then clean. So this one is the scenario we can say, or the model of the system. In the end, maybe for example low battery, maybe you can add here low battery or no dirt, finished, all the room is clean, so go home and off. So this is just how we model the system, such system. This one is the design, also similar to this one. What's the design of these vacuums? So we have sensors, we have battery, we have also a CPU in this machine. We have also the carpet sweeper. This is the one it will clean. We have also the motor to steep or to move the device. Also there is a network, or we can say network card, also motor to control the ports. So this is just as the internal or we can say internal components of these vacuums. What's this? Okay, this is the scenario how it's work. Okay, receive, I mean this is how this vacuum works. So just is the normal scenario similar to this exactly, but here it's based on similar to this scenario, but here only for the vacuums. Okay, receive the information from the sensor on the distance measurements, and then predictably call the navigators and control the algorithms. This is how the vacuum cleaner works. Okay, so one of our what we can say topics in this course, we will study the sequence diagram. The sequence diagram, because if you see here, it's important for us to know the scenario, right? To know the scenario of the system. So we will learn one class is just to learn the sequence diagram of these systems. Because as you see is we have sequence to follow. I mean, as you learn the sequence, okay, the first step, second step, third step. So here is it's important for study the autonomous system to learn this sequence diagram, but will be a little bit different than others. Okay, will be the same, but maybe only the components of this sequence diagram will be different. Sorry, guys. So, guys, also the second example, we just go fast. No need to, because this one we not study, guys, the devices. We not study. I mean, for example, these devices. We just want to see the components. What the difference between this device with another normal system, not with other autonomous system, with other the normal system, which is information system. Here we have some input, but this input based on sensors, and these sensors just only to receive the information from the environment. So here we have another example, which is unmanned vehicles. Unmanned vehicles. So here this kind, we have many kind of this vehicle. This vehicle, if you see here, we have unmanned vehicles. The name is come from this U, unmanned, and then vehicles. We have X, it's based on the what we can say is the based on the function of these vehicles. So we have ground vehicles, we have aerial vehicles or air vehicles, aerial, okay, meter. We have Martin, we have also sensors. So we have what these vehicles actually, guys, maybe there's some photos here more explanation what's mean by UGV, UG, and then UAV, and then UUV. This one is just as we see is all its unmanned vehicles, and some of them is based on the ground, that means it's walk on the ground, and then aerials, that means it's in the air like the aircraft, and some is underwater, that's why they call it UUV, and some is this surface, on the surface. So this is another kind of autonomous system, or also semi-autonomous system. Okay. Okay. So here the hardware of the hardware, okay, similar to others, we have some mechanical components like the driver, the power, the chassis. Okay, guys, you know what I'm talking about? Talking about these things, these vehicles. So these vehicles, as you see, okay, is normal vehicles, but here it's work for some to do some job. Okay, so maybe some job it's there is risk if there is if the human take use it or do it. So this is can do it. Okay, so it can be used in the military, can be used, for example, for check the car. So this kind of vehicles, it's actually also can consider as autonomous system. So here the components of these vehicles, as we say, we have the hardware components, we have some electronic, we have also is communication system. Communication system, maybe there is some parts of sensors. We have control system also, maybe this is part of this protocols, smart protocol. Actually, this is just the element of these vehicles. Also, some of them, like this, maybe we can say is also it's semi-autonomous if not controlling by uh, another device, but most of them is controlling by another device. That's why here we say is interface. So interface, that means it will be controlled by another devices. So here the elements, the hardware and the software, the elements of these vehicles, the elements of the vehicle. So we have environments, okay, and these environments interact with this hardware. So what the hardware here, we have the sensor to receive the information from the environments, and then this is the information will be received by the software. This one now, if you see here, what's this? This is exactly the control loop of autonomous system. Receive the information, plan the information, and then control. So here the control to the actuators. Maybe later we'll know more about the actuators. Actuators actually is the movement. Anything is related to the movement in the robots or in these vehicles or in this machine. It's, we can say, is actuator. For example, removing the arms, moving the arms, not removing, moving the arms. So this is, it's the job of actuators. So here also this is the techniques that maybe can control. Yeah, that's why I put it here. Control the this communication. So V2X, something vehicles to everything. So this is techniques to control this or to communicate these parts. So this is the same these figures. We have the same figures. So here how this kind of autonomous system works. So similar to others, it's starting by receiving the information from the output or from the input devices such sensors, and then process this information. After that, react based on that information. So here is just scenario how this kind of autonomous system, which is unmanned vehicles, works. So here just, okay, this is actually, this is not for you, but I added from last year, but this is just, I mean, for the one who designed the robots, okay, but we study, it's okay, we design, we study the design, okay, we can consider as we are the designer. So there is something like you should not when you design any robot, you should not harm the human, okay, you should not hurt the human. This is, you should put it in your mind. Robots must obey the order of the human. Okay, should be, and the robot should protect its own existing along as much as protection. Also should protect the others. So here just some laws, some laws. As we say, this is for the designer, for the design, but we study the design of the robot. Okay, guys, we come to the not first assignment. Actually, this is one of our project. Okay, one task of the project. Okay, guys, I want you to submit. Okay, by next week. Okay, by next week.